Hi everyone, it's Mrs. Francis, and I'm here with you for the long-awaited dimensional analysis tutorial. Are you feeling a little bit like this? I think a lot of kids feel like this with dimensional analysis, but hopefully I can make it nice and easy for you guys. So I'm going to start this way. This is dimensional analysis. Or we call it railroading. Okay, and the whole point of dimensional analysis or railroading is to convert from one set of units to another. So really, this is about conversion. Okay, two main things that you're going to need from your problem in order to make dimensional analysis work. Number one is called the starting quantity. And the starting quantity describes to us what you actually have. So it is the amount you actually have or the amount that's given in the problem. And we're going to use the abbreviation SQ for starting quantity. The second thing that you need is conversion factor or factors. And so let's talk about some of the things that make something a conversion factor. So if you say 1 foot is equal to 12 inches, this is a conversion factor, and the equal sign tells us that we can convert from feet to inches. Other things that you might see are the word per. You might see a colon, like a ratio. Or you might have something like this, where we say 1 foot over 12 inches. And even this is a conversion factor. Okay, now you need to have the right conversion factors for the right problem. So I'm going to start with just kind of a simple type of problem for us. And I have some practice problems available for you. It's called like dimensional analysis and conversion practice. And so if you're struggling with this, I encourage you to do those. And then I think I can get a key for you for those. So let's just start with this simple example. And the question's going to read like this. How many kilometers, okay, and that's km, are in 8 miles? Okay, so the first thing I'm going to do is I'm going to ask myself, what is the starting quantity? Well, I know this problem is asking about 8 miles, and we want to convert it into kilometers. So this is my starting quantity. Now, the way that we like to set this up in dimensional analysis or railroading is we're going to put the 8 miles on the far left side, and we're going to put this in the numerator of a problem. And then we like to just extend the line out here for the next part. Now, the second thing we need is a conversion factor. Now, sometimes we need more than one conversion factor, but for this one, I went and looked up how many miles to a kilometer or how many kilometers to a mile. And so I found out that the conversion factor is that there are 0.625 miles in 1 kilometer. Those two things are equal to each other. So now what I'll do is I want to get rid of the miles unit, and I am going to put my up and down line here. This essentially is like the dot in math. Okay, so in math class, you might take and kind of do it like this, all right? And then you'd put the dot, and then you'd put the parentheses around the next part. So I'm going to say 8 miles, and then this is like the trick. So here we've got starting quantity here. The starting quantity unit is going to help us to know where to put these things. So a lot of times students will say, do I just multiply? Do I divide? I always say, I don't know. Because what I will do in order to make this happen is whatever unit I have here in the numerator, it also needs to appear in the next segment of the railroad in the opposite position. So if miles is here, it's going to be diagonal from this, and I'm going to write miles here. So notice I'm not starting with a number, I'm just starting with the unit. I want it to be like that because I want miles and miles to cancel out. If miles is in the numerator and in the denominator, they will cancel out. So now all I have to do is look at my conversion factor, and whatever number appears before the word miles, I'm going to write that there. 0.625 miles. And then so since I've used this side, whatever is on the opposite side of that equal sign is going to go now in the numerator. Okay, so I'm going to say 1 km or kilometer. So now the units of miles cancel out. Now to put this into the calculator, technically it's 8 times 1, that's 8, divided by 0.625. So I just do 8. I could put the times 1 in if I wanted, but that's a waste of my time. And now I get 12.8. So I'm going to write 12.8 kilometers. We have converted from miles to kilometers. In other words, we can now make a new conversion factor. We can say that 8 miles is equal to 12.8 kilometers. Do you see how that actually has told us the equality? In fact, sometimes conversion factors are also called equalities. Okay, so just to be really literal about it here, this in the calculator is 8 times 1 divided by 0.625. That's in the calculator view. Okay, now sometimes students ask what goes underneath here. Well, really nothing, but I like to just say it's really a 1. Okay, that's what's really there. Now, let's try a second problem in which we have some more factors to deal with. Okay, let's try, I'm just looking actually for a different type of problem. Let's see. Let's do this. The average student, so this is my example 2. Okay, the average student is in class 330 minutes per, I'm going to just do this for per day. Okay, so one of the questions that we could ask is how many hours per day is this? Okay, or we could do how many hours per year is this? Let's try that second one because it's a little more complicated. Let's try that. So this is my information. I'm going to start with my starting quantity. Now, I'm doing these problems authentically with you. In other words, I'm making this problem up. And so you're going to see my thinking as we move along. So 330 minutes, I'm just going to use minutes, per day. That is my starting quantity. Per how many days? Per 1 day. Okay, sometimes putting that 1 is helpful. Okay, now we have a choice. We can start by converting the minutes, or we can start by converting the days. I'm going to start by, I don't know, let's do the days into years, okay, because we need to get this one and we need to get this one. So days. If day is down here in the denominator, it now needs to appear here in the numerator. So do I know a conversion factor that will get us from days to year? Well, yeah, we know that. We know that 365 days equals 1 year. Okay, so the number that appears before days is 365. And now, since I've already used this one, all I have left is 1 year, and 1 year goes underneath. Now day and day cancel out. If I were to solve the problem right now and put it into my calculator, 330 times 365, I would have how many minutes per year? Does that make sense? Okay, now I want to keep going because I'm trying to get to hours per year. Okay, so with this hours per year, I need to get from minutes to hours, and we know a conversion factor for this. We know that there are 60 minutes, and that equals 1 hour. So minutes is in the numerator. This is my next available slot on the railroad, and so I'm going to put minutes. Notice again, I am putting the unit before I put the number. It's a habit I've gotten myself into. So now I can pick 60 minutes, and 60 minutes is one part of the conversion factor, and 1 hour is the second part. And now minutes in the numerator is going to cancel with minutes in the denominator. All right, then I'm going to go ahead and multiply and divide this out. Now, what this is going to look like in the calculator is really 330 times 365 times 1, which you don't really have to put that in there. And then it's really divided by 1, divided by 1, divided by 60. Okay, so I'm going to take and do that in my calculator now. 330 times 365 times 1 divided by, well, I don't really need to divide by 1. I don't really need to divide by 1. I'll divide by 60 here. And I get 2007.5. Now, what are my units? Look at what's left here. We've got hours in the numerator. That's all that's left up there. And years in the denominator. So we now have this many hours per year that a student attends school. All right, so hopefully that's making some sense for us. Okay, now, did you notice I knew a lot of these, which I think you know a lot of these off the top of your head. On the conversion sheet practice that I have, there's a ton of these where I've given them to you. We also have the conversion factors from the metric conversion. So there are 1,000 of the unit, so either a meter, a liter, or a gram in 1 kilogram. There are 100 in the hecto. There's 10 in the deca. Okay, now this works opposite here when you get to the smaller. So here we'll say there's 1,000 milliliters in 1 unit. There's 100 centimeters in 1 unit and 10 decimeters in 1 unit. So this, I believe I have available for you guys, this metric conversion sheet. I'm pretty sure I've got it up on Schoology for you. Okay, let's go to one of our problems that I told you guys that I would look at. And I am going to do this in the moment, meaning I'm trying to make my thinking available to you. So if we have from our map that we have 120, let's see, it was gram, cal. I think it was actually lower cal. I have to double check here. I think it is. Okay. And so I'm making my G bigger so it looks normal. Per meter squared per day, I believe. What a pain in the tush. Okay, so first of all, I'm going to say this. These slashes are horrible for doing dimensional analysis. So I'm going to first deal with that. 120 gram cals per meter squared per day. So what I want you to see is technically you have a fraction in the denominator. Now, I'm going to show you how this works out, but then once I show you how it works out, you can just kind of take the cheater method here on this. So if meters squared per day, if I multiply in the numerator of the denominator, am I making sense there? Day here, those cancel out. But I'd also have to do the same thing here, multiply by day, okay? So what I end up with is 120 gram cal days. Talk about a strange unit. Per meter squared. Now, I prefer to do it this way so that I can use my dimensional analysis. Oh, you guys, I think I was wrong. It must have been big C. I apologize. My handwriting was not clear to my own self when I had written the numbers down. Okay, so we're going to take this 120 gram cal days per meter squared. That's my starting quantity. Now the problem on here, oh wait, you can't see that way. Okay. Oh yeah, look at, I have it right at the top of my page, is asking for this unit. So we're trying to, our goal in this, I'm going to just write that this is our goal, is kilogram cal per meter squared per year. Okay, again, we see that fraction and a fraction. What you can do is you know that whatever is in the denominator of the denominator ends up here. Do you see how it ends up in the numerator, just like it did here? Okay, so now the things that we are off on, in other words, the things that we need to change are grams. We've got to get those into kilograms. Oh, that marker's terrible. And we need to get days into years. And actually, those conversions aren't too bad. So let's just deal with one and then deal with the other. So I want to convert grams into kilograms. So if grams is in the numerator, I am going to put grams in the denominator. Now going back to this, we can say that 1 kilogram is 1,000 grams. 1 kilogram is 1,000 grams. So 1 kilogram equals 1,000 grams. So now I'm going to put the 1,000 in front of my gram and the 1 kilogram here. So now grams and grams cancels out. All right, now we need to change days into years. Wait a second, we just did that a minute ago. We said 365 days equals 1 year. Okay, so if day is in the numerator, we're going to put day here in the next available spot. And we look at our conversion factor, 365 days, doesn't matter if it's plural or not, per 1 year. So day and day. Okay, now I want to check to make sure I have the right units. kg, or cal, year. Yeah, that looks right. Oh, and meters squared down here, so I think we're good. Okay, so in the calculator, I am essentially, okay, now this is really good to talk about this calculator action here. So technically, this is 120 times 1 times 1, which we all know is 120. It is divided by 1, because there's 1 meter squared, divided by 1,000, divided by 365. Why do I keep saying divided, but then I keep putting these dots? I'm saying divided because it's in the denominator. So this is divided by 1,000 and it is divided by 365. So you have two ways you could do this. You can multiply across and get two numbers and then put those two numbers in the calculator. Or you can do like this, 120 times 1 times 1 divided by 1,000. And I just usually hit the equal, divided by 365. And I get this pretty darn small number. Okay, now you might write this out. I'm a chemist, so this stuff drives me crazy. I would not write it like this. I would go 1, 2, 3, 4, and I would write 3.2877 times 10 to the negative 4 kg year per meter squared. And you're like, well, that doesn't look like it because the year's got to be in the bottom. Well, I can divide by a year here, and I can divide by a year here, and I'm back to my units that I needed. All right, folks, I hope that this has helped you. Feel free to watch it again. Feel free to come and ask me some questions. If we think that there is an error, please let me know. But I am hoping that you don't feel like this anymore. All right, everybody, have a great day. I'll talk to you soon.